present. We are to begin with 4-day session of FDP today. So a very good morning to Honorable Speaker, Mr. Sachin Atreja, Professor Nitin Srivastava, faculty members, scholars, distinguished guests of the day. I, Ayush Trivedi, on behalf of Mechanical Engineering Department of PSIT and PSIT College of Engineering, welcome you once again to today's session of 1-week faculty development program covering machine design and manufacturing science and technology. Being organized by the Department of Mechanical Engineering, PSIT Kanpur, and sponsored by Dr. APJ Abdul Kalam Technical University, Lucknow. So before we get on to the start of the session, I would like to call upon and request Professor Nitin Srivastava sir to kindly facilitate and welcome Mr. Sachin Atreja sir by presenting him the bouquet. To some industrial approach over academics. So now I would like to share something about today's speaker, that is Mr. Sachin Atreja sir. Mr. Sachin Atreja is here with us to manifest and enlighten us with the recent in machine tools and inserts. Mr. Atreja has specialization in production and he is working with Sandvik Asia as territory manager. Sandvik is one of the oldest and biggest tool and tooling solution company. It has roughly around 45,000 employees globally with sales force in 150 plus countries. Mr. Atreja is responsible for providing cost-effective as well as productivity-enhancing solutions to industries in the territory. He is also involved in providing solutions for difficult-to-machine problems. He is an experienced dignitary having experience of more than 13 years in a row with specialization in channel management, customer training and rotating tools. Mr. Atreja will enlighten us on machine tools and inserts as I have told you. So I now begin with technical session first, and I would like to invite Mr. Atreja to address the gathering, please. Please, thank you.
Introduction of, I'll quickly share the agenda for today. We'll start with a small presentation about brief history of Sandvik as well as the manufacturing industry. How does it touch our life every day? And with that, we will discuss the what has been prompting us to develop new solutions. Why are we doing it every day? Why are we developing new solutions? Why do we need new solutions? First part is that. And then we slowly move to whatever is happening today. What are the new trends that are getting implemented each day as we encounter each problem? And in the next half, after the post-lunch session, we will look at things. What does the future hold for us? What are the current needs that are asking us to develop new things, new tools, new ways of working? So I would request you all that this is not a training session. This is an interaction. So if you feel that you have a doubt, you have some input, because this is not a one-way communication. If you wish to learn things, then you will have to share what you are thinking and what is your expectation of us. Right? So my expectation is very simple. Please come back with your doubts, questions, queries. Right? Today I am presenting this on behalf of Sandvik government. My name is Sachin. This is my colleague Rajnish and JB Ranjan as well. All three of us are responsible for this. We start with the emphasis on training, on safety, and in this room, I believe you must be aware that the safety exits are just across the road. I am Sachin Atreja. I am based in Noida, And I'm looking after the complete territory. In north of India, I have worked in Chandigarh, Ludhiana, Delhi, mostly UP, Ghaziabad, Meerut, Agra. And what I have been doing in the last these 15 years, I passed out in 2000 from the production engineering department. So in the last 15-17 years, I have done masters as well from Sydney, and I have been working in the industry since 2001. So in all 15-16 years of experience, with 13 years of exclusive experience in cutting tools. Cutting tools means we do not go there and sell tools. We provide solutions. We go to the customer, ask for their problems and help them solve. Yeah. So I'll start with how the manufacturing industry is today. Manufacturing industry, we come in contact with the manufacturing industry every day, every hour and every second. Each thing that we use, we touch, is being manufactured somewhere. So in a way, we are part of such a big universe, but still we are all connected with the manufacturing industry. Not only this, manufacturing industry is responsible for employment and profitability of a country. How many of you know how much GDP, how much percentage of GDP is manufacturing in India? How many people are employed in India in manufacturing industry? If we go by Government of India data, about 16.5% of our GDP is through manufacturing. 16.5.
16.5.
Yes. And about 23 is from agriculture and 53 is from services. Services including all the railways, electricity, infrastructure and all that. Manufacturing means only the manufacturing part where factories are there. We manufacture something, we produce something. We take the raw material and give an end result. The physical part, we touch things. This is actual manufacturing. Otherwise, we term it as services. For example, software. For example, radios. For example, cellular mobile. So these are services. In India, about 16.5% of the GDP, which means more than 435,000 crores, is Indian GDP and employment. Now this industry, this is not the same thing as past. Today the industry is growing rapidly. This is not our needs. Even they have not remained the same. The things that we did in past, we wanted in past, are no longer there. We were very happy with radio. We were very happy with black and white TV. But still, today the needs have changed. And the same thing has happened with the industry as well. The industry has to cope up with the amount of shift in needs, requirements of everyday person. So what does that mean? It means that these things, they have to, these are the global trends, not only India, like digitalization. We also have started to embrace that, and we also have started to do that. And why? To increase on automation. Just to beat global competition, we have to do these things. And what is sustainability? What happened to Nokia?
We were not able to meet the market trends.
Today they are not sustainable. Why?
because
Everyone
they
had a thought of
did
that.
not
There
know
will be so many.
the
Yes. I totally agree. There will be so many. But they could not cope up with the change.
Bigger example is Hindustan Motors.
Yes, ambassador.
Ambassador. बम्पर चेंज करने के अलावा कुछ नहीं किया.
Exactly. One of the finest cars in the past. And now people prefer K10 because it is a better engine. So, the only constant thing in today's world is change. And what is the biggest challenge in change? Everybody wants that. Everybody wants change. Everybody wants new phones, new cars, new laptops. More features. More ease. I should be more comfortable in doing whatever it is. We invented phone to be productive, by the way, which has become joke of the century. We invented phone just to be productive. And it has been the reason of most of our non-productivity. And I'm not blaming WhatsApp. I'm just blaming phone. The guy who invented phone never thought about that. So, why change? Why change? And this knowledge gap. Can you get the idea of what is knowledge gap? Knowledge gap is one organization has some knowledge, other doesn't. That is knowledge gap. Eventually it fills up. But the new entrant into the market, Amazon, they started selling goods. Nobody else did. Today they are one of the biggest sellers of all the products. That is knowledge gap. They knew at that point what they wanted to do 10 years later. And today we can compete with them. They won't let us. They will not let others enter into it. So, what are the key things that an industry does to achieve this? What is the greatest challenge to digitalization? Everybody wants digitalization. Everybody wants plastic money. Everything on a card, on a chip. You bring your phone there and you do the Paytm. Yes, everybody wants that, right? Because it is easier. The biggest challenge to change is the change. We want the change. We do not want to change. Human tendency, nothing personal. I am not talking about it. This is human nature. Everybody wants change to everybody wants change, but nobody wants to change. So that is a dilemma which our generation holds. This is something different from the generations before. The previous generations also, they had intention, they wanted to change, but then the change was not very often. The process of change was very slow. So either we did not perceive it in a negative way, but today the industry, the requirement, the needs, they change every day. If we see a phone, a tablet, a PC today, after 1 week it will be old. So the speed of change is increasing. And industry, who has to compete with it? ISCO, who wants to be with the change? The industry. Because if this industry will not do, some Jeff Bezos will come, some you remember who invented Hotmail? It's not too long ago. It's not too long ago, and we can't remember who invented Hotmail.
engineer from Bangalore, from Bhatia.
Yes.
And you're the first one. So we-
पार्टी है याद करता हूँ पंजाबी में आती है so yes you are right but then how long ago was that it was not more than 10 years it was like
2008.
2008 or something it's not actually 10 years so may I request everybody to put the mobile on side because if I forget then you forget and this is not crammed up this is coming from the experience so the more we interact the better our discussions will be right so for the sake of everybody let us what is here right so the constant thing about change is it is going to change. If today is happy, then tomorrow will be happier, not sad. Right? And in the same way, we at Chandvik also, our organization started exactly 75 years ago. The main organization, Chandvik, started 154 years ago. Chandvik government, in this year, completed 75 years. We just started from a simple rolling steel plant. And what is so different about it? It was the first steel rolling plant. We established the Bessemer process to develop steel. Earlier, everybody in the department should be aware of that. Earlier, the steel manufacturing was not so easy. There were a lot of people who were working on it. And the commercialization, the final experimentation and putting money banking on was done by Chandvik. Even today, it is one of the key areas in which we develop steel. Today, we do not develop normal steel, carbon steel. We develop high specialty steel. So, has anybody heard of Gillette? They use 90% of steel as Chandvik.
Chandvik is one of the largest manufacturers of specialty steel, especially for laser blades.
Yes. So if you touch a blade, a knife, you are touching Chandvik. And what else? You touch Chandvik every day, by the way. You touch this logo every day. For example, the cars you drive, the Honda scooters you drive, the Hero motorcycles you drive, they are machined by Chandvik. You have heard about the mission to Mars, the Indian ISRO one, and they claimed, and they are right, they claimed कि ऑटो रिक्शा से कम खर्चे में, है ना, मंगलयान, है ना, तो what did they claim? And how was that possible? Because they used one of our customers is a vendor to ISRO and he made the casing. The casing of the Mangalyaan is so. I'm not here to market it. I'm just I'm helping you visualize that manufacturing and Chandvik go hand in hand. And when I say Chandvik, you imagine I'm saying manufacturing. So you come across technology every day. If India wouldn't have done it in a cheaper way, how would they have got the mileage in global community? Today is a competitive world. Whom did we beat when we जब हमने मंगलयान भेजा and it was one of the cheapest one and it really was. Whom did we compete with? And why? First of all, किससे compete किया and why did we compete? We competed with United States of America. है ना? हम fantasize क्या करते हैं? United States of America. But we are doing it here. The future is here. India is growing at a hell of a speed. जब हम बस में बैठे होते हैं, मोमेंट ऑफ इनर्शिया देखो, तो when we are sitting in the bus, we do not feel like moving. We are in that bus right now, and world is watching. So coming back to the point, first point is we competed with NASA, and why did we compete? For the sake of it, we wanted to compete. There is no other way. If we will compete, only then we will sustain. Otherwise, we will buy things from, we will outsource it. We want to manufacture it here. If it is viable to manufacture it here, only then we will manufacture it here. Otherwise, we will buy it from China. है ना? Half of the satellites will fly, and that would be a good ratio. So that is the part about manufacturing. We come across manufacturing every day, and it has to be sustainable. These are going to be the key takeaways from today's interaction. Right? It all started with steel, just steel, and then they introduced a department named cutting tools. They named it Coromant. Only we hold the logo of Sandvik. Nobody else. We have 18 companies inside Sandvik umbrella. Only we are allowed to take the logo along. We are Sandvik Coromant. So only our company is allowed to have this logo. Why is that? Because a lot of reasons. We are pioneers in so many things and we are profitable. But important is this brand was started 75, exactly 75 years ago, in 1942. So and then just after 4 years, just like most of the startups are there, in the beginning of the phase, there is a high probability that it will fail. So just after 4 years, Sandvik decides that Coromant will not exist. Coromant will cease. We do not find it suitable area to invest in money. It is all about money. So, couple of guys, one of them is Willem Ackland and one is Fairham, something like that. So these two guys were made in charge and told, okay, this is your last chance and whatever you want to do, you do. You must have heard about competition of Sandvik. First of all, have you heard about Sandvik before? No. Yes. So if you have heard, good. Then our competition is also very old. So like BMW and Mercedes. Nobody is bad, but everybody is doing the things they. If I forget now, please remind me what I was talking about, because I have very interesting story. You know, very recently BMW completed like 150 years into business, and Mercedes congratulated them. And how did they congratulate them? They said, thank you for being there for the last 150 years. We love your competition. So, the same thing. After 4 years, they decided that this organization will not exist. This is not making much inroads into the market. So, let us stop this here now. Let us stop making any more investments into this. So, two guys are given the charge, go and find out if we can do something. Now industry is going into some direction. Cutting tool industry just budding. Nobody knew what cutting tools are. Cutting tools at that moment meant HS bars. Cutting steel with high speed steel bars. And industry is budding and they want to grow. Now, one of our competition decides to go into X direction. They say we are going to manufacture ceramic inserts. Some ceramic tools. And these two guys said, no, we wish to develop, we call it indexable these days. At those times they were called throwaway tips.
Throw in such a.
Throwaway tips. So that was a game changer for everybody, for customers. At that time, if you remember, 1946, the wars were ending. So World War II just ended. And things were returning to normalcy. Life was going on in a rapid pace. Everybody wanted new products, good products, refrigerator, car, AC. In developed countries, in underdeveloped as well, there was a lot of people were getting freedom and they wanted roads. So for roads they needed trucks, they needed to rail. So market was booming. Everybody had a lot of work. You know? But capacity was less. Machines तो उतनी है, लोग भी उतने हैं. आज की सिचुएशन में क्या है? Today we are dealing with the same problem. Day after day. For last 75 years, we are dealing with the same problem every day. The machines are same, the people are same. We wish to produce more. So they decided to introduce throwaway bits. People said they are crazy. These guys are crazy. They do not know what they are talking about. Nobody will accept who throws such an expensive carbide tip. Who throws away such an expensive carbide tip? But it was a huge hit because why did it happen? Why would I throw away a tool? A good perfect tool which can work after refinishing.
Waste time in sharpening, you don't have to waste.
Exactly.
You get another thing and start production.
You buy 10 tools and you use 3 and then you go and regrind it. है ना? So your productive time is getting shortened. So if I have a use away tip, what will I do? It will get worn out and throw it away and put another one. How many minutes? Not more than 2 seconds. है ना? So what did that mean? It meant that the business now was profitable and it was growing. And that was not the end. It is where it started.
Your competition with media, you are going to
And in assemblies we do not make our competition, but then everybody is doing it.
But anyway, you're the leaders in the rock drilling and those aspects. In fact, that is the major.
There is a reason to everything. Our core business is cutting tools. On the other hand, the competition which you are mentioning is not their core business. Their core business is machine business. Their core business is making machines, selling machines. This is side business. Our side business is steel. Our core business is chemicals. That is why we are doing. And this is where we started. And this is where we really changed the game. First we mentioned the throwaway bit. It was, then we also understood the market. After we did a few trials, then we made customer को ये चाहिए. So even today our approach remains the same. We work as a. There are two ways to a situation. Either you are part of a solution or you are part of a. So we went to the other side of the table. And the problem was when I look at the customer, when Sandy looks at the customer, they used to see opportunity of doing business here in this pocket and doing business in this pocket. As soon as I turned my back here, I was very clear. Sandy was very clear what do they want. They were seeing problems in the customer's face. We were never worried about our business. As long as we were solving customers' problems. We were doing their work and they were doing ours. We never worried about it. And even today, even in the today's industry, we rarely go and ask for it. We rarely go and say, sir, give me one. The reason is, we one of the main is we go and look out for customer problems, and not only problems. The customers share their problems, and out of 10, 9 could be small problems. We look for these ones. If I am able to work on these big problems, if I solve only one problem, only one big problem, my 9 small problems actually fade away. They are symptoms. The 9 problems are symptoms. The problem is one big problem. And the worst part is, when I am looking at the customer, I cannot see that problem. Unless and until I am working shoulder to shoulder with that customer. If I know what he is going through every day. So, what is today's customer challenge? I'll explain. Yes, please. So, we started with indexable inserts, and then we used to make carbide inserts. Do you understand what is carbide? Anybody?
Iron carbide.
Iron
Iron carbide.
No. Yes, that is why I wanted to come to this bit. Do you know, when we talk about cutting tools, we generally say carbide inserts, carbide tools, solid carbide. Yeah? Have you heard this terminology? So what is that carbide? That is not iron carbide. That is tungsten carbide. Tungsten carbide. Have we got a consensus in that is tungsten carbide? है? So the tools and inserts are made of tungsten carbide. Now I'll put a comma and say mainly. The main content of a tool or a cutting material is tungsten carbide, as you said. So, would you like to see how an insert is made? What is the process? How a tool is made? What is the process? I will skip this part and will come to this again. But that is an interesting part. That will put things into perspective. And then there will be a question after that. And whoever answers that, I will clarify. In the next round, there will be incentive. I'll let the video play for play once, and then I'll mute the video again when I play it the second time. First time you observe what is happening, and then I'll explain what is happening. Right? no touch here. How many people touch the tool? Nobody touches the tool. Everything is done by robots, computers, robots. Even the inspection is done without touching the tool. And why is that important? Computers do not make mistakes.
No margin for error, yes.
People sometimes make mistakes. Computers never make mistakes. A person can make a mistake in running the computer, but the computer will do as it is told. So, when you look at the box, it carries a batch number. There will be about 10 to 30,000 of same tool manufactured in the same box. So, if one tool is not as per specification, that would mean another 29,000 tools would be also not as per. So that is why human involvement is left to only academics. So this is a classic question when we say that today, earlier it used to be machines will take away human jobs, which as you can see it has already has. But did you spot a few people running around in the factory? The same question holds today as well. Will computers take away the human jobs? Would they? Chances are very less. We will graduate to the next
Yes,
level.
it will shift to a different level. Jobs will not
We
go.
eventually, we cannot always kill time on WhatsApp. We will eventually need some work to do. So, that is a classic. Now coming back to the point, I'll put the video on mute and we'll see how the result is made. So, when I show you this, the main ingredient in any cutting tool is tungsten carbide. That is for sure. But then we do not always cut steel. We cut a lot of materials, which we will cover in the next session. What all materials we will. So, based on the material that we machine, we use the ingredients. And the main ingredients of any tool are tungsten carbide, tantalum carbide, niobium carbide, zirconium. Which one? Silicon carbide is one of the, but then it is used in a known manner. That is a ceramic. We are actually that is a ceramic. What is silicon carbide? Now that you have started. I'll break my thought process and I'll start on something else which is very interesting. So we'll do this. Before that we will do ceramic. So what is silicon carbide? Anybody? Has anybody seen silicon carbide in its raw state? Everybody of us have. Everybody.
Everybody at this side.
Exactly. Silicon carbide is sand. And who thought of manufacturing a tool out of sand? Who thought of it? What was the need? Of course, nothing happens on its own. Why was silicon carbide tools developed? You can go to Google and search them. I will give you a hint. In World War II, there were two parties fighting about it. And one was, of course, the Europeans and these Britishers, Americans, and Russians. And on the other hand, it was Germany and Japan. So, but the Allied forces decided to stop their petroleum and the supply of tools. So, the main manufacturer was Austria. Austria used to make, even today, they make 70% of tungsten carbide.
Yes.
So, they stopped their supplies. That we are going to win the war because we have stopped their supplies. No petroleum, they won't live without petroleum. How will their tanks run? How will their things run? And the machines also were diesel operated. They used to run on diesel. They used to run on fuels. Not much electricity was there to run these shops. So they cut down their supplies of oil and tools. So what they generally did was they produced oil from coal. They made synthetic oil from coal and survived because that is Germany. Only he can do it. They decided they cannot rely on Europe for oil. So developed oil from coal. And the next step was Japan. They developed tools from silicon carbide. Now the best part about silicon carbide is it is harder than tungsten carbide. Now like all hard things, they are brittle. Just like sand. So they break very easily. Now when the World War was over and everybody appreciated that they have developed the ceramic tools. Now how to deal with such a brittle material. So they added tungsten carbide to it. And today it is known as ceramic metal. Cement is one of the finest products for finishing of steel. So this is the history of cement. So we were coming to, and the main ingredient apart from tungsten carbide is now all these materials. These are heavy metals, and these are in a powder form. How to bind them? How to get them into one place? How to join them? We use we will enjoy more if you मेरी आवाज से आधी भी करो. मेरे को आंसर यहाँ तक आधा बोलते हैं. We will come to second. We will come to second. Process. What is the main ingredient that we are missing?
Binding.
Which will bind all the sand particles together.
By heating.
I will give it starts with C. It's cobalt. Like a soldering material, its melting temperature is lesser than carbide, tungsten carbide. So when we heat the mixture, the cobalt melts, and when it cools down, it holds the carbide together. ठीक है? अब इतना तामझाम करने के लिए how do we get these things along? इन सारे पाउडर्स को हम कैसे मिक्स करें? We use alcohol, and why alcohol? We make a slurry with alcohol. Why slurry? Because it is easy to handle. And why alcohol?
It can be evaporated.
Absolutely. It evaporates as soon as it reaches 70-80 degrees. So we get pure powder. We don't have any moisture. So we store these different powders in different containers, and then when we want to make different type of inserts, we use some 5% this and 10% this, and so we hang all these containers upside down, and the machines decide how much quantity goes into each insert. The powder is still manufactured in Sweden. By the way, this video is of this is normal. What you have seen is press and die and punch. Since the alcohol has evaporated, we are left with insert blanks. Now at this stage, we can mold it into any shape. It is just like a casting. This is mixture of casting and forging because you are using a press. You are using a press to make a mold type of thing. So this is similar to making brick. So what we do is, but what is different, so different about it? I will explain. Now at this stage, this is very brittle because the cobalt has not yet gripped the tungsten carbide. Now we put it into sintering. Sintering is a process in which we heat this mixture for like 12 hours straight, but in a controlled state, so that it reaches the melting point of cobalt, but doesn't reach the breaking point of the meaning that we have now. So, jalna jale, bun jati hai. So we do this. This is called sintering process. This is heating up of the inserts. The major part what happens is the size of the blank, what we designed earlier in the present type, the die and punch. After heating, after sintering, it is reduced by half the size. So when I design my punch and die, how much size should be there? And how to do it on the corners and how to do it on the edges is where humans are involved. Computer cannot decide that. So at this stage, tool is ready.
In fact, you can see that the edge there is more rounder. It cannot be used for turning as compared to what you achieved here.
So someone must tell the computer that this should be the size before I am planning to do this. You please do that. And this is not as simple as it looks, because the size here would contract in some other manner. The size here would contract in some other manner, because there is a lot of carbide here and there is a very less carbide here. They will compress it very, but then my final, and each insert should be of the same size. Why? Because of the holder which I am using, the tool in which this is going. If it is not of the uniform size, it will not fit, or it will fit very poorly. Right? At this stage, my insert is ready. Can it be used for machining? Who said that? Absolutely right, but these inserts are usable. People use it today as well. These are called sintered inserts. These are uncoated inserts. If you have heard about DPKN, SFAN, these inserts are ready to use. This is pure carbide and you can cut material with that. With a few limitations, of course. We will not run at very high speed. But of course, the final inserts will be ready, the good inserts, the modern inserts will be ready after we do some post-treatment, some coating, some value, except for maybe ceramics. Ceramics do not need coating. Interesting? Before coating, now my insert blank is ready. It can be used for machining. So what else should I do? I should grind it so that I create the clearance angles, the rakes. So that those are sharper, those are perfect to my requirement. For example, one main difference. The insert that you are seeing on the video is a milling insert. And how did I know that? Because turning inserts have corner radius. They have edge rounding. The milling inserts have? बोलो गलत already knew, I wouldn't be here. है ना? तो मजा तभी आएगा. Let us participate. So, who was? This is no wrong answer. I'll explain why radius and why chamfer. Did I answer it? The milling inserts have bevels and chambers. May I have a
Marker.
which one is turning? Which one is the turning tool and which one is the milling tool? And what is the difference? Please go ahead. Do not ask for.
First item for turning, sir, and second one is for milling.
Yes. So, why turning? Why do I need a radius on a turning insert and bevel or a chamfer on a milling insert?
For turning point.
Why do I need this? Why can't I make it sharp? Why can't it be like that?
Strength will be not there.
Absolutely. If it is not rounded or chamfered, it will break. This is a brittle piece of glass. Tungsten carbide is very close to glass. If you heat it and then if you send it in cycles of heat and cold, it will develop thermal cracks. It will break. Yes, it happens all the time. It happens all the time. So when I give radius, it gives a smooth contact across the surface. My turning tools tend to stay in cut longer. They stay in cut until the cut is over. In milling, what happens?
It changes.
It comes into contact and then goes out of contact in matter of few milliseconds. So it is constantly in interrupted cut. It handles interruptions all the time. So to handle the interruptions and to avoid breakage, I give it a chamfer. Why not chamfer on a turning insert if it is such an advantage? Why not a chamfer on turning insert? Because it creates a lot of friction. Yes, it increases the friction. It increases the cutting load. So that is that. So when I see which insert is this, because it has a land here. That is why I can say this is a chamfer, and chamfer milling operation is going on. And after grinding, this is decreasing. Why decreasing? What do you think is the process that is going to happen after this? Why do I want to remove the oil that has been deposited by the previous grinding machine or something like
Because it will be clean and we will put it.
that? Absolutely. This is the operation before rotating. I am removing the dust, the grease, the oil, so that my coating is evenly deposited. Right? This is just buffing and all. These are surface cleaning operations happening. They are cleaning the inserts so that they are ready for coating. Now, let us assume that one particle of dust has not been removed. What will happen? Only one, not many, only one. Only one particle is still there
The insert
before
will
coating.
wear- The insert will wear after that coating,
both there you are. The insert will wear after running.
coating will not be there.
The coating will peel off from the point where dust particle is there. At a temperature of, how much is the temperature when we are machining things? When we are machining steel, it is about 1200 degrees centigrade. If I am machining steel, if I am machining stainless steel or exotic metal, it is even higher. So that is the difference between average insert, running insert, and sometimes we do tests and some inserts work better and some do not. Of the same type, that the reason is that proper quality control is not done. So post operation is done. Now comes the most interesting part. This is edge rounding. By the way, we do edge rounding on turning wheel board. And there are turning inserts with chamfer where hard material is there. We need chamfer. So there is no hard rule that we cannot have chamfer. Now the inserts are ready for coating. The process shown here is CVD, chemical vapor deposition. There are two types of coating. One is chemical vapor deposition, another is PVD, physical vapor deposition. I will explain more. First of all, do we understand why do we need coating? Do we need coating? Why do we need coating?
Durability.
Durability.
Hardness.
Corrosion.
Strength increasing.
Yes.
Core level.
Surface hardness.
Coating will never increase the core hardness.
Because this is not done at greater than 800 degrees, never greater than 800 degrees. So it can never change the properties of the tool. It is just a superficial operation. The thickness of modern coatings is less than 10 microns. Anyways, it was never more than 30 microns. So when I am talking about thick coating, I mean 30 microns. So when I am talking about very fine coating, that means 6-7 microns. Right? So why do we need coating? We need corrosion resistance. We need friction, less friction.
Less friction.
We need less friction. We need resistance to thermal, working as a thermal barrier, resistance to thermal conductivity. Because at 1200 degrees centigrade, anything is supposed to burn. Even if it means after half an hour, after 15 minutes, or something like that. So if I delay the amount of heat that is conducted into the tungsten carbide, I increase its time. I increase the duration. So that is why coating is important.
सर कोटिंग किस मटेरियल की
COATI.
नहीं किस मटेरियल्स की कोटिंग की जाती है
हाँ, that I
Actually, we can break for T.
okay.
we bring a break for this
Whenever it is.
No,
This will go on forever.
no, we can break for T.
Coatings are of two types. One is CVD and PVD. The coatings started from tin coating, and now they have started to do titanium coating and titanium carbonate as well. PICN coated. Titanium is TIA.
Tennis like
Right. So first of all, why now we have covered why we need coating. Two types of coating. One is CVD and one is PVD. CVD coating is similar to this one shows that there is an inert gas and inert atmosphere from where the foreign particles cannot enter, and then we fill the area with the coating that we need to do. So what will happen? There will be a cloud of whatever we want to coat, and it will slowly get deposited just like raindrops. Alright. So the coating will be deposited on the inside, and the inside will look something like this. Advantages we know about this process. This is easy to do and this is least expensive. What are the disadvantages? The disadvantages are that the uniformity of coating is not there. Somewhere it will deposit more, somewhere it will deposit less. And we cannot ascertain how much amount we can deposit. So that is the limitation of this coating. The advantage is, of course, it gives a thicker layer. This is a 12-hour process. We do a thick coating. So all the roughing operations we use cement. Chemical paper deposition. Chemical papers are deposited on a side, just like rain. It is easy to understand. There is a cloud, and when we pass the insert through that, coating gets deposited. Another way is PVD, physical paper deposition. It is similar to the gold plating process. So we have a few electrodes, and in those electrodes we have material which we want to deposit. And on the positive side we have inserts. The inserts have positive charge. So, but now what is the advantage of this? I can decide how much material can be deposited. Yes, I can decide how much can be. What can be deposited, how much can be deposited, when it can be deposited. Now I can have multiple layers. For 5 minutes I will put this coating, for another 5 I will put this. And then this cycle will go on for another 6 to 10 hours. So what I have is, I have 1000 layers of the coating that I want in the manner which I want. Got it? So what is the advantage? Now in lesser coating thickness, I can achieve more. I have मैं पहले एक नंबर लेके सोता था, अब मैं 4 नंबर लेके सोता हूँ. I have more thermal barriers between. There is a air barrier in between the surface, right? So this is the difference, and how do we, if I now we are all engineers, so I should know by looking at the inside which is PVD and which is CVD. Can you please pass it on? After I will explain.
So is there any effect of coating based on the material or the basic material? Is there any effect of coating?
That is the next point. So I will explain. The cutting glue material or job material? The job material. It has got everything to do with job material. What I will explain is how it differs from cutting glue material.
How it will the different size of the coating? What amount of coating deposition is there?
Yes, that is decided by the team of designers. Because not each coating works well, so they conduct trials in our R&D.
So between 10 to 30 microns, what is the preferable size of coating?
There are two different processes. CVD can never deposit less than 25 microns. CVD process cannot go below that, and PVD cannot go beyond 10 microns. Because after that it will below. The top layer will below. I cannot put unlimited breads on a table. They will eventually follow. Huh? So there is a limitation to what we can do and what we cannot. Yes.
So, can we apply the CBT activity to any group? Or there
Yes,
is
we
certain,
can. Yes, we can. I will explain more.
so there is no restriction to apply.
I will explain what is the restriction and how we overcome
There are
it.
precautions, no restriction.
How we overcome that limitation, I will explain. But then how can you differentiate between the inserts? When I am depositing in a chemical vapor type of coating, the coating will be distributed everywhere on top of the surface, inside the holes, everywhere.
But the side surface,
Everywhere. It is a vapor. It will get deposited on the sides.
but the bottom.
Sir,
At the bottom it will, but they ensure that it is open on the bottom. They design the fixture like that, that insert is getting proper vapor. Vapor is easy to reach everywhere. Vapor is easy to reach everywhere, so it will get deposited on each surface. Visually, when we look, it will be even everywhere. Now, this is electroplating type, physical material. Now, the material that is to be deposited starts from here and ends up here. So it will get deposited here. This will rotate. Yeah, बहुत सारे electrodes होंगे. So it will get deposited on the sides. So if you look inside the insert, there will be no coating. So the insert which you are holding in the hand is CVD or PVD? Physical.
clamping more में deposit नहीं है. Clamping more में deposit नहीं है.
This process is very similar to case hardening process. Case hardening, like carbide is like
It is
very good.
almost. Now, why coming back to your question? Coming back to your question, the tungsten carbide or the carbide insert is not suitable for coating because we are depositing a similar material on a similar. For example, we are depositing titanium nitride or titanium carbonitride on a tungsten carbide material. So it doesn't tend to stick. They are not very affinity. So what we do is we introduce a material which holds together. So what we do is a single layer of a material which is compatible with wood. So we do a CN coating, and then on top of that we put a thermal barrier, that is alumina, Al2O3. Alumina is a very good thermal barrier. And on top of that we put the additive that we want. So that is the coating part. We will after that the inserts are inspected and packed and the insert out. So this is more of inserts. We will continue later. Yeah,
Inspection or what?
this is all considered. You know, this is the Sweden unit which is shown in the video. There is a same insert manufacturing plant in Pune as well, and all of you can go and have a look whenever you want to. You just need to intimate a few days ago, and we can request them to.
But this is an old plant. Pune would be a new plant.
That is what I am coming to. The only difference between Pune plant and Sweden plant is that you are seeing a lot of boras there. Over there you will find it. No difference.
Same plant. ये तो बहुत पुराना है और भी change कर दिया automation और आया होगा.
Nothing new has happened in insert manufacturing. Insert,
हाँ वो नहीं बदला है.
insert materials have changed. The process remains the same.
नहीं. Right.
We'll continue after the break. Attention. How was the first session? This session is going to be more intense. So I want more questions. not questions, answers. You decide. Correct? First question. Where did we leave? On this slide.
On 14.
At the 1969.
Whoever said that has said right. We were discussing gamma coated inserts. Before coating, we used to make tools, but then they did not use to last long. They never used to cope up with the heats of metal cutting. So before 1990, there were a lot of developments in the core material of the tool. That is the base tungsten carbide, or maybe the ingredients which were organic elements which were added, and the properties of cobalt and all that. But after 1990, because who challenges us in our field? If I am at top of my game, if Sandvik is #1 player in cutting tools, who challenges me to be even higher? There must be somebody who is going to challenge me that you cannot do this. There must be somebody. There is always somebody. So if I am a player in one industry, and the industry looks up at me, that look at that guy, he is doing good. So what gives me motivation to go ahead? Allied industries, my peer companies. Who is my peer company in what I do? Those are machine tools. The machine tool industry grew like anything in this area from 1980 to 2000. Powerful machines. They had so much power. But what to do of power when there is no tool to control it? Right? So we had to come up with a solution that could bear higher heat during machining. So we came up with coating. And then of course it is an industry trend, and everybody else also started developing new coatings. Right? And then started the multi-service concept, that is we do not only produce tools or sell tools, we also provide the service part of it. For example, ring industry, for example, drills, for example, providing different solutions to the same industry. Right? For example, now we supply to gearbox manufacturers. Right? Now, these dates are mentioned because these were groundbreaking technologies, and our industry acknowledges these events because these have been registered in the industry, not with Sandvik. These have been registered with the, for example, if you must have heard about Corvette Capco, this was a patented product with Sandvik. Sandvik gave away the patent so that industry could graduate to that level. Now it is ISO standard. Anybody can make Corvette Capco. Anybody can make Capco. It is such a fantastic thing. Why? Because it is as good as rigid tool, and it is applicable on convenient rigid. I will approach that.
Capital.
Capco we do not have right here, but I will show you what is there. And then silent tools. As the name suggests, silent tools are tools that are used on long overhangs. Right? If I need to machine something that is very long, so the tendency of my tool will be to vibrate. Why? Because it is a cantilever. So when I put some load on cantilever at the far end of the cantilever, it tends to bend very simple. है ना? The cantilever has a tendency to bend. I stop that movement and I become world number one. As simple as that. It is the biggest problem in the industry even today. The people who are aware and are using these tools, these are not very old tools, see 2008. But the industry relies only on this, just to avoid violations. What if there is violation? I do not use it. What happens then? Think like a businessman. Think like a person who owns a factory, who buys this tool. What if there is violation? What will happen? Too late. Success quality. Cycle time. Where will cycle time go? How much time will it need to? For example, I need to avoid vibration, so I will go very slowly. So the job that I would have done in 10 minutes, I am doing it in 3 hours. What is the cost of those 3 hours? We will discuss. Find that and I'll show you in the next session. I wanted to show how does a tool stop vibrating by itself. It is a technology that cannot be imitated. It cannot be copied. Since the patent involves the process of how that thing will be done, it cannot be copied. I'll show you in the next session. So, next big thing was in-bio coating technology. In-bio is now when we coat things, when we do the coating, the particles they are deposited in a haphazard manner. We let the particles go and they get deposited in any direction. So if there are two different particles, they may arrange in any shape. Whatever R&D and designers did, they found a new way to do the coating so that all the coating particles were aligned in one direction. What did this do? In 6 microns, we are least worried about it. Acted as a barrier. Otherwise, heat could have escaped through crevices. Now it has no space to. Now I can put more thermal barrier. So this was a groundbreaking technology very recently, not more than 4 years ago. Coro Plus. We have named it Coro Plus because this represents the new change that is very evident in our industry. Can anybody recall how many industrial revolutions, the things which have changed the complete industry by itself, just by being present? 4 industrial revolutions in manufacturing have been here. The first one was steam engine. We could now translate energy into motion. That was our first industrial revolution. Now we had an engine which could put things into motion. Right? What is the next industrial revolution that we came across in manufacturing? Machines. Industrial revolution after World War, there were a lot of machines. The work that humans used to do was now being done by machines. This was our next industrial revolution. The third one, which is very obvious and we hardly notice it. Today everything is touched by very close. Computers. So in 1990s we came across an industrial revolution which changed the complete pace of manufacturing. We now had a computer to help us do things. Imagine how good we would have done designing so complex parts without computers. We used to have a drafter, we still practice that. I practice like that. But no more, not required. CAD and CAM have changed it for everybody. And that is one part of it. So that is third industrial revolution. The fourth industrial revolution is happening right now. Currently, not many players are aware or working on it, but it is still best about part about revolution is we hardly notice it when it is happening. The fourth industrial revolution is cloud computing. The next future is Industry 4.0, they call it. Everybody, they call it Industry 4.0. The meaning of that is fourth industrial revolution. The fourth major impact on our industry, on any industry, is cloud computing. What is cloud computing? No data is saved on any machine, and all the machines communicate with the
Cloud service.
server. So all the information is available with server. Who takes the action? Somebody has to do action to do the revolution. Who takes the action? Who is the action person there? The machine, the robots, the CNC machines, the tools. The tools are equipped. We go to a toll plaza and there is a fast tag there. What is that? It is cloud computing. It has a chip. The sensor reads the chip and says this car is allowed to go. It is not saved anywhere. It is saved in the server. That is cloud computing. The next future is my boring car will have a chip which is going to be launched in 2018. That chip will tell I am running at 50% okay, 15% load of the machine and I am running okay. My load has suddenly jacked up to 18% or 20%, whatever the load limit is. My load has increased, what should I do? It will ask the computer, it will ask the server. There will be set replies to that. reduce speed or something like that, change the program, reduce speed of car. Whatever good practices we know as humans, we will get into that. So the first action will be taken by machine itself and it will get corrected by itself. Let us take a very simple example. I am changing a diameter. The diameter shifts 0.3 mm due to, let us say, inside gear or material different or something like that. So the diameter changes by a few microns. The computer lets the server know that the diameter has changed by this much. The server's first step, is it acceptable to make this diameter? Yes or no? No, take corrective action. What corrective action? Whatever is written in the flow diagram. That is the next step. So this Coro Plus are the new generation of tools that are going to be ready for that revolution. The class act of a leader is it is always ahead of the revolution. अगर मेरे को पता ही नहीं चला revolution आई और चली गई तो किस बात का लीडर है ना? First we should know what is changed. Coming back to the first point. First is knowing what is changed, then accepting that it has changed. Third is to change. And the fourth aspect is most difficult. Let your people change as well. Organization will change. People will never change. People will change after बहुत सारी training, बहुत सारा inputs, बहुत सारा efforts. Organization has to spend a lot of time, effort, money on changing the mentality, the acceptance level of people. Computers will change like that. They will change the program, they will change. We as humans, rarely. Coming back to topic. On the 75th anniversary of Sandwich, we have introduced yet another tool that is going to change the industry. Now, if you go to Sandwich's website, its cover page has an advertisement that says biggest innovation in turning since turning. This is the biggest innovation in turning operation since the turning operation itself. This is this big. And we are not making up anything. Because for the first time, we have a tool that can work in any direction. But it is showing that the phone has graduated to smartphones, the typewriter has graduated to laptops and iPads. The maps, the way we used to do, have now been turned into Google Maps and online maps. So what is there you will tell me. The general recommendation before today was to go towards chuck in turning operation, either towards chuck or towards center, so that we could break the chucks. For the first time, we are doing it other way around and faster than the previous. See. We are doing it away from the chuck. We showed this to a customer that, sir, this is the new way of doing things. And he said, you only said that it is good if we go towards chuck. Now you yourself are saying that, sir, it is no longer the right way. But times change, technology change, needs change, and solutions are developed as per that. So what is so different about it? It is faster, it is cheaper, and it is all directional, so that no corner is left from each other. And all this can be done with two tools only. So we have an example as well. Whatever time we used to take to machine a pinion, we have reduced that time by 30%. Now, we can use this tool for turning in all directions without taking off the tool and at a higher speed.
यहाँ पे ये blue dots जो दिखा रहा है show कर रहा है direction.
Blue dots are conventional way of turning. So for blue, the parameters are maximum depth of cut less than 1.5 mm, AP is depth of cut, FN is feet per revolution, which is maximum 0.25 mm per revolution.
Conventional.
In conventional turning. If I go for unconventional turning, the depth of cut is doubled and feed rate as well. What does that mean? That I can, the job I used to finish in, let's say, 10 minutes, I can do it in 5 minutes.
It is better than the conventional solution.
Of course.
That is what I do.
That is why it is innovation, biggest innovation in turning since turning. It is better than conventional turning. We claim this as the biggest innovation of our times. I am almost done with the introduction part. The more fun is in introduction. Introduction will go. So we are part of Sandvik group, and I represent Sandvik Government. We represent Sandvik employees more than 45,000 employees globally. Scientific government has 8,000, close to 8,000 employees globally and present in 120 countries as well. And in India, we have about 4,000 employees working in all departments, scientific, not scientific government, but scientific. And we have plants in Mehsana, Hyderabad, Pune, three main plants.
Sachin, we are making all the inserts in India, or some are in India and some we import from other plants?
We used to make about 80% inserts in India and about 10% steel tools. Now the variety has gone up because of the trends the slow trends in Europe. Now we are preferred supplier. We come next to Japan. Only Japan is efficient and sustainable. So India is considered one of the best manufacturing facilities in China. And this is not related to price. This is also related to price, but that is not the governing criteria. The rejection rates, the delivery commitments, these two are the major criteria. And India is the best. This is our lifeline. If we do not do this, we will go out of business any day. 6 new products every day. The day we do not discover a new product, we will vanish from this. Because the customer, the end user, has a lot of options in buying tools, conducting business, and not necessarily those are very highly priced. When you copy something, your price goes down. That is why we have about 3,000 patents with us. And this is per capita, one of the highest in the world. After IT के बाद our electronic tools industry is the highest in patents. Only information technology has more patents than our industry. We run on innovation. We do not run on profits. We run on innovation. The day we stop thinking about customers' problems, right?
Sir, you have own machines to testing all these tools.
There are 3 phases to developing a product. Our development period used to be 3 years to develop a product, which we think in 3 years the industry changes by itself. Then we fast tracked few innovations. So now we have about 1.5 years, about slightly higher than 1.5 years time of launching a new product. See, launching a new product is not a big thing. Getting it accepted from the customer is the big thing. I cannot launch a product which is a failure in the market. So to do that, it is coming back to okay, how long the question was we do the new developments.
Yeah, suppose you have worked a lot for a new invention, the new innovation, and launched in the market. And at that time, the trends are changed in the market.
So what we do is, first it is a concept. Every new idea is a concept in its initial stages. The first stage is concept. After that, we prototype it. When we prototype it, we do a lot of trials in R&D. In our own workshop, we have a very good workshop in which we use the tools and run it. After that, it goes to our preferred customers for testing. Those are called field preparation tests. So we test our to be launched tools at live customers. And at that stage, we have about 4 or 5 variants of the, for example, I am going to launch a new insert. So I will have 5 different inserts of 5 different properties and give it to 5 different customers. Based on the results of that, I will decide which grade needs to be manufactured, because manufacturing is a capital investment. I need to spend money to manufacture something. When I am trying something, I can make 10, 20, 50, 100 inserts. But when I am manufacturing, I have to make 30,000, 40,000, 50,000. So the distance should not be long. So what I do is, I run a market preparation test. I select 10 globally. We select a few customers, let's say 50 customers or 100 customers. We send them 3 samples, sir, please try. So they come up with feedback. So actual development doesn't take long. It takes maybe 1.5, 2 months, 3 months max.
But the test results takes some time.
Validating those results takes time. For example, when we talk about environmental inserts, the project took about 3 years. Just because the market preparation test took close to 1 year. And after that, we do that one.
So before physical testing, there was a test and the software also.
Of course, because we have to know the physical properties of the tool. I cannot assume that it is going to happen. One more interesting thing. Anything that is launched into the market by Sandy or by anybody else, let us say motor, let us say washing machine, TV, anything. So it has to be tested for safety before they launch into the market, especially in Europe, America, everywhere. So they have to test it for safety. So every tool has some recommended parameters written over it or something. So how do these parameters come into picture? What they do is they try out in R&D and take it to extreme and multiply it by 5 and then test it again. If it doesn't pose any threat to human beings or machines, only then it is logical. Because you never know when the accident will happen. And in accidents, the actual speed would be comparable to the one specific. So, when the machine is in rapid, only then we can know if the safety hazard is. So, all the tools that scientific launches have a safety factor of about 80%. Otherwise, they do not go, they scrap them. And we scrap the bits, yes, we have to. We cannot launch everything into the market. But then, of course, when we develop a product, the most important part comes with the yes.
Sir, are you using 3D printed tools also?
That is the future.
And I was watching that you are using technology. I think the same tool can be manufactured by 3D printer also.
Yes, you are right. 3D printing can be done with easily handled. This is not so easy. We can manufacture tools with that. Very recently, we have made the press form of injection molding. So nobody else can do it, only we have done it. So this is the latest version of our innovation. But yet time to realize it is not impossible to do whatever we have. But then it has not yet. It is basically for prototype. It is not for prototype. It is very slow
For
process.
this system, you'll be making in say 10 seconds, 70, 80 inches.
Yes.
Whereas with 3D printing, however fast you make it, but no, you will not be able to make 4 or 5 in say 5 axis.
Below a minute you cannot do anything.
It's not possible, it's printing. It's traveling, the idle movements are there, deposit layer by layer, point one each time. Here your bulk entirely is one shot. At die punch, you do it in one shot. So once you've done it in one shot, here one travel, let's say for example 1 second. There one travel of 1 second is produced full piece.
But can we get the same
So that,
property by?
yes, you can get. You can get.
Can we get the same property by 3D printing or the punching process?
In punching as well, we are not making the finished component, so it doesn't matter. 3D printing is also
Well, it's same.
not so. But then, of course, the problem is productivity. We cannot afford to make one insert. We need to make thousands of inserts. So that is the big problem. But then, we are developing solution not as a tool provider. 3D printing has to be हमारे काम के स्पेयर में आना ही है।
वो आना है कि आपको सैंपल डेवलप जल्दी भी करना पड़ता है।
In future तो आ जाएगा।
We already have solutions based on it, but not in cutting tool. We provide certain solutions. We do designing part.
Sir, you said that creating acceptance for any innovation is the major concern. That the customer accept the product. So this implies that you don't ask the customer what is your problem. You first design the thing and then impose or ask them to try it out.
Yes.
So how do you say that you have understood the problem that they were facing?
Not every time we are able to solve the need which. This is not about problem and solving. This is about need and addressing it. Sometimes our assessment may be right or wrong. Sometimes the customer needs less costly tools rather than complicated.
No, actually, I have this question. Since there was a point shown that 2100 patents.
Yes.
So all these patents were based on needs, I think so.
Best part about R&D department. R&D department is answerable to no one.
Okay.
No. The reason is R&D is a creative job. When we put restrictions that you have to think like that only, you have to make a business sense out of every business idea, out of every idea, then the R&D department fails. They should have a complete freedom to decide what to do. We can only guide. They have a figures. Sales department is the governing part of organization. Any organization moves around sales only. For example, I will ask my team to focus on these areas. So I give 3-4 areas similar. Out of 150 countries, every country will give their own areas. But then, whom to cater and when to cater, that is decided by. Now R&D department is working on their projects and it is not making any business. Doesn't make sense. So they have innovations, they incorporate in the tools which are going to be launched.
Actually, हम इसमें एक और बताते हैं मेरे एक्सपीरियंस से जो ये 3100 के होंगे या 2000 किसी और के होंगे नॉर्मली क्या होता है नॉर्मली स्टैटिस्टिकली करीब 60 to 70% नीड बेस्ड रिसर्च
Yes.
जिसमें आपका प्रॉब्लम था जिसकी वजह से हमने सोल्यूशन ढूंढा लेकिन 30 to 40% वो करते करते निकलते हैं
And those are not
कर रहे थे बाई प्रोडक्ट निकला है अच्छा ये आ तो गया इसको एक ग्रैब कर इसको पेटेंट करो कल हो सकता है चीज जरूरत फॉर एग्जाम्पल आज हमारा गाड़ी में टायर पंचर का सीलिंग का कोई एरर नहीं है बट आज एक गाड़ी आ रही है जीप का पास जिसमें जो टायर टेक्नोलॉजी है छोटे मोटे छेद वो सेल्फ सीलिंग करेगा मतलब आपकी गाड़ी रुकेगी अब ये पेटेंट पहले बन चुका है ये अवेलेबल टेक्नोलॉजी आज से 15 साल पहले मैंने सुनी ये न्यूज में नहीं आया क्योंकि उसका इस तरह का रोज ही नहीं 30% is need-based, 20-25% is byproducts. Only within 10% is क्या कहते हैं वो bright idea innovation, bright idea. ये एकदम से आइंस्टाइन बन गया. वो 10%.
Eureka.
Eureka.
Similar Sandvik, in Sandvik as well, we have some Eureka moments.
Oh.
So one of the operators in Sweden plant was working. Now there are insert type drills. We used to call them U-drills. So the limitation of that was that when you drill the hole for coolant in them, so they used to break out around all the bad parts of the drill. They were never uniform. Sometimes they used to get into pocket. So somebody was working on an idea. So they twisted a piece of metal after heating them. Just a normal thing in a workshop. So he was a two-room guy and he bent the rod or something like that. That fellow patented this idea. And if you see modern drills, anybody's drill, those all are made with the same material.
मशीन से लैंड नहीं बनता.
So now what they do is they take a straight drill, they drill the hole straight and then they twist it. So now the coolant hole is also spiral. It doesn't foul out into some other way. So these are Eureka movements. It tells more about our organization, our DNA, what we do. We share knowledge. We not only share knowledge with customers, we also share knowledge with the next generation. Even we have good development programs in Sweden, India, everywhere. We like to involve young people because that is what is missing from the manufacturing industry. Everything else is available. Machines are available, computers are available. People are not available. Good people are certainly not available. So we, not from today, but Sandvik has been imparting knowledge, sharing knowledge. And another is presence, continuous progress and collaboration. Collaboration is good for customers. So what we say to them is, you do your job and we will work as a partner, as a technology partner. You focus on your work and while we focus on how you better your work. And this continuous progress, I would like to spend half a minute on it. Why should a company be progressive? Why should it grow every year? Why should it be profitable? Why should it make any organization? Why should it make money? If a company is not making money, what will happen? It will not be sustainable. It will be sold out. Somebody else will buy it or shut it off. So, any company that is making profit is a good company. Any company that is not making profit is a not so good company. So, नाम नहीं लूँगा. काफी सारी कंपनी इंडिया में प्रॉफिट नहीं करती, एक्सेप्ट फॉर जियो. Small video on our last 75 years, what were we doing?
We've gone from local to global, from analog to digital. But 75 years, a lot has happened since we first started. The world has changed. People have changed. We've gone from local to global, from analog to digital. At the forefront of industrial progress, we've relentlessly been solving a transition from braze to indexable inserts, coating technology, customer support, next day delivery. We brought what was to become the standard system for quick change and a modular tool. Together with both customers and schools, we have exchanged an abundance of knowledge through manuals and courses. Over the years, our ingenuity and determination have given us thousands of patents, with innovations spanning from atom-level coatings and geometries to vibration-free tool technologies and smart digital solutions. What once began a modest workshop in San Vito has over time transformed into a global industry leader. At the very core of our DNA lies a passion for engineering and pushing boundaries. Always in close relationship with our customers. It's been a part of our culture for the last 75 years, and it will continue for the years to come. Together, we shape the future of manufacturing.
This is your promise to our customers. We promise them that we will not look at your problem from an individual perspective. We will see the picture as a whole. We will not provide a solution. We may or may not provide a solution which is dependent on only one view of the perspective. And then we also promise them that we will find you the most competitive way to fight this competition. We may provide you a solution that may look and slightly expensive, but that is a tool that will help do the job in a better way. And that is the expertise. We are in a service industry. We tend to give away the physical tools as well. But the main job that Chandni Corporate does at the customer is providing the free consultative level. We can guide in refining the processes, making the processes better. So it is the know-how and expertise that sets us apart from the competition. The R&D section we already, I already shared. Now, what do you think? I will share like this. We are more than double in spending on R&D than our nearest competitor. We have about 500 people working out of 8,000 people, which is roughly 8%. 8% people always working on R&D. And these people are not operator level people. In R&D, you always have PhD, doctor level, something level. So about 500 well-educated, good people doing and masters and then pursuing doctorate. So 500 people doing this innovation. Why? Because we cannot live without 500 patent families. Now, as rightly said, not all patents will be used in a business form of way. But then one day they might use it. One day they might. When technology shifts, it is dependent on these innovations only. Now, in terms of value, if Sandvik does rupees 100 rupees of business in a year, let us assume Sandvik does a 100 rupees global sender. Then it spends 4 rupees, 4% of that on a nobody else does. Nobody else needs to do it. The nearest allied industry would be car industry because they have to come up with new models. And what they do is a backup data capture. Not too many innovations in the market. And in that market, we are here. 4% not of profit. Profit is profit, 15-20%. If my profit is 15-20% and I am spending 4% on that, it is really amazing. What do we offer? We offer state-of-the-art tools as a physical package. This is what we provide. This is what we give to the customer. The tools shown here all have been launched within last year. These are not more than 2 years old. And then methods and technologies, new processes, new ways, better ways, not necessarily new ways. See, prime learning. It is not about the tool. It was not included in the tools. It is the way of working which has changed. Enviro technology, silent tools. Even Zertigo technology is similar to Enviro, but this is applicable in billing. Can you see these dots? What is that? Gray structure? Good answer. There are 5 ingredients in a insert. One is tungsten carbide, titanium, tantalum, niobium. This is the one. There is a term called cobalt enrichment. So my tool is always cutting from the corner. My tool is always cutting from the corner. I do not need strength in this portion because this is not cutting. Got it? Inside the bottom level. So my tool is cutting from this point. This portion is not engaged. Do I need strength in that? Not really. Not required. When this is not getting engaged, why do I need strength? So what I do is I do a process that enriches this portion with, I pull out the cobalt towards the cutting edge. What does that do? It makes my cutting edge more tough. It doesn't break. It brittly rather. It doesn't remain that brittle. So it resists fracture. Now I can safely run this tool. The insert will not break. So that is part of process, not of tool. I have changed the process in which the tool is made. Right? And then is services. This word comes again, but in this slide, the meaning is different. This is related to environment and etc.
Without harming the environment.
Yes. This is sustainability of human race. Only Sandvik does the recycling of carbide inserts. We have a plant in Chittoor. We buy used carbide inserts from the we crush them and use the same material. Why it is not coming into health and safety? It is a health and safety concern because these are heavy metals and the mining is not very either easy to do or it is very accessible to do. And these are natural resources. One day they will be finished. So Sandvik uses 70% of their carbide as used carbide. Nobody else does. So this is something which makes us proud. By the way, if a customer sells us the used inserts at a good price, whatever market price is, we provide them with a health and safety certificate, which is helpful in their documentation. Whenever they get a quality standard certified, they need a certificate that they are doing their best for health and safety. So we do that. We are expected to do engineering. We are expected to help in manufacturing, and without logistics, we can never do this. These are the two things which we are doing for the society and not for the profit. Some of the customers, Boeing, Liebherr, Renault, most of them, we touch everybody. Scania is a truck manufacturer from Sweden. Now they are present in India. Magna makes parts for motorcycles, Kawasaki, BMW. Indian names as well.
Engineering. It can change the world. It goes beyond materials, tools, and calculations. It's about questioning what's here and imagining what is not. It's to fight for progress, turning knowledge into value, and never settling for good enough. It brings expertise together, challenges you to take unknown paths, and make unexpected turns. To move forward and to keep going. It turns hours into milliseconds, blunt tools into sharp scalpels, and complex processes into a synchronized clockwork. Engineering is to rethink, redesign, and redefine. To understand what is around the corner, and to figure out what's possible to achieve. Together, we always push for progress. Together, we shape the future of manufacturing.
Future of manufacturing. This is what I was talking about. Fourth industrial revolution for us. Now, what is included in that? It says that we have connected solutions in design and planning. We design tools in such a way that they can interact with the machines, the samples. Now, for example, this boring bar, this has a chip inside, and what he is monitoring is how much load it is giving the machine, it is how much load it is. and then advanced machining analytics. What do I do with that data? The industry has graduated to a level now the data can be reached. Data, we can access the data. How much load is generated? How much heat is produced? What to do with that data? Now what do I do? Is advanced machining analytics. If this happens, do this. If this happens, do this. Else press 9 to talk to operator. Self-help. Operators will still be there. No matter how many industry 4.0 or 4 plus will come. Humans will never be eliminated. They will be graduated to the next level. They will have more important tasks to do. This is additives. What we call 3D printing, we call them additives. We still are in the try out phase. We haven't yet made a model which is going to help the customer as well. You know what is the main area where digital manufacturing or additives or 3D printing, what is the use? Where can it be marketed well? Where will people pay to use that? It is fluid. Where will people use that? What is the advantage of 3D printing? You can make any shape. You can make any shape, any complicated shape. You can make all the curves, all the radius, all the chambers. And you can do that all this inside the surface. In machining, you can do on the outer surface. In additives or in 3D printing, you can do it inside the surface. That is the main application of 3D printing. That is why it is not a threat to machining. It is basically an enabler. It is enabler. The more this will happen, the more manufacturing will do. So what is actually the application where 3D printing should and is already started getting noticed? Even in India, people are investing in good setup. Basically, human parts. One of my customers makes dental implants. It is much easier and faster than machining. And he can make each line perfect what he wants to make. Just because he can do it on a computer. Right? And why a slow process is still acceptable? Because each human is unique. Each human has a different tooth. Each human has a different bone. Each human has a different bone density. So each human needs a different part to be replaced. And we have of course 306 bones. So we don't know which one needs to change. So you can always design and change only that part of the body which needs to be changed. That is the main application area of, and of course the components which are not made in mass production. For example, how many satellites do we send in India? India based looking, so otherwise not. So if a component is made 10 components in India, you can always 3D print it. It will be cheaper and better. These are the applications. In mass production, it cannot match the production of a CNC machine. Right? The softwares on both the machines are same. The 3D printing machine software and because ultimately it is a computer and you are programming it to do some tasks. If I break it down to simple tasks, both are doing the same thing. Right? One is machining and another is depositing material. So both are complementing each other. These are enablers. We were missing this part earlier. Now we have this part. But of course, manufacturing industry is growing now, but it is expected to be slightly slower level than previous years. This is how I end my introduction part. Now we'll
break for lunch.
break for lunch. After this, we will start with the actual
Action.
Correct. So even if there is a competition sitting here, it is an advantage for them.
ये एंटी वाइब्रेशन है
Yes.
क्या नया कुछ लगाया है क्या इसमें हाइड्रोलिक अटैक
Yes. This is the reason why nobody can come close to us.
पहले तो हाइड्रोलिक बेस था ऑयल
हाँ वही इसके अंदर की मैकेनिज्म यही है तो आई एक्सप्लेन
ओके स्टार्ट यस
गुड आफ्टरनून पोस्ट लंच इज ऑलवेज वेरी इंटरेस्टिंग सेशन
It's called a graveyard session.
actually it is the we call it a challenge round now I have a challenge keep you awake for the next 1 hour right that is why I am showing you one of the key technological innovations that Stanley has done in the last few years. Can you see that on top? That is the mechanism of a silent or anti-vibration tool. This mechanism, what it does, if a normal tool is vibrating, like a cantilever, I am putting if I am putting the cutting load here, there is some tendency for the cantilever to vibrate. Right? Right? Everybody on the same page? What it does differently? There is a loose piece of carbide floating in a gel. Consider it as a grease or oil. There is a lubricating oil in which there is a carbide piece suspended. So when my cantilever vibrates, the loose piece vibrates in the opposite direction and cancels out the. What does it cancel out?
वाइब्रेशन
This is my challenge. So I am on to it, don't worry. I will give you. So when the suspended carbide part vibrates in the opposite direction, it generates the opposite vibrations as generated by the cutting load, right? So it cancels out the vibrations, right? Coming back to the favorite topic. This is what I promised before lunch, that next session will start with this. Yeah, I missed this video. This is something interesting as well. This is normal turning operation, right? This is normal turning operation on a lathe machine or CNC lathe machine, right? So when I am doing a finishing pass, what happens? What is the when I am doing a finishing operation? What is my requirement? What should I get? A finishing part. What is the meaning of finishing part? The surface roughness should be less. Surface roughness should be less. Surface finish should be more. है ना? In a finishing operation, the chips foul on the face and generate bad surface finish on the face. My cut chips touch the surface and deteriorate the surface finish. है ना? Now this problem is automatically handled by prime learning. Why? Because it starts from the face. Some things we develop, other things get developed.
अच्छा रिवर्स करने में लोडिंग्स पूरी चेंज हो जाती है.
You are absolutely right, sir. The load increases about 1.5 to 1.8.
हाँ, तो उसके लिए टूल होल्डर्स चेंज करने पड़ेंगे क्या?
Tool holders तो change करने ही पड़ेंगे. The most important part, which is not covered in any presentation, is that you need a rigid setup.
हाँ, मशीन का रिजिडिटी भी चेंज डिफरेंट
So
होगी.
you cannot implement new tools on a old.
एस की जॉब में तो नहीं लग सकते.
This will require high-end machines, DMGs,
हाँ,
machine.
वो मकीनो जी चाहिए होगा.
You will
स्पेशली टूल पोस्ट रिजिडिटी बहुत हाई चाहिए.
Yes, especially these are very suitable for VTLs where
Ah,
components are very big. You do not need that much RPM per minute. But then
हाँ, किसी का देख लो रिवर्स करोगे तो लोड्स बहुत बढ़ जाएगा.
yes, this is a tool which if a customer asks, please give me this tool, we send our application specialist to
सही है, सही है. He has to see whether the setup
whether it will
is
work or not.
ठीक.
One more interesting video on total price, and then we move on to
ये प्राइम वाले ही चल रहा है.
this was prime, na? So one value is not additional numbers. Any specific query, or shall I play a video of my choice? There is a video.
बोलो.
is the do's and don'ts. That we need either a rigid component or the component should be, because we are taking it away from the chuck. It shouldn't come out of the chuck. We conducted few tests in our Pune facility. For the first time, our BMC machine component back to it. To form the component. For the first time in our life. So you are absolutely right. The load is very high.
वैसे नहीं सफेद हाँ, लेकिन इसमें एक एडवांटेज है, शोल्डर कटिंग बहुत अच्छी होती है।
Yes. We have two lines of insert A and B. A is for finishing. So this is conventional view of it. And this is primer. Away from surface primer. This is again primer. Finish cut. Normal level.
So it is the actual material or animated material?
This is actual.
Actually,
Not any.
चिप लपेट रहा
Now you know it is actual because it is not breaking.
और चिप लपेट रहा ये तो वीडियो के लिए बिना कूलेंट चलाते हैं, अगर बिना कूलेंट चलेगा और बचेगा दिखाई नहीं देगा।
Modern grades do not require cutting.
हाँ, now there is a change of course.
This is normal way of turning a pinion. This is a gear basically. Pinion shaft, there is a gear.
ऐसा लगेगा कि थकेगा ऐसे।
This is explaining how it was done earlier before price and how much time and how many tools did it take. This is actually industry scenario here. This graph is complete now UPMD for finishing.
Time 60 seconds.
कितना टाइम था?
60 seconds. हाँ?
How much is part?
Right, right.
Same component right turning.
That's it. आवाज सुनाई दे रही है?
This is unique because when we go away from chuck, it is impossible to break things except with priming. How much time saved?
20 seconds.
1/3 of the time saved just by changing one tool and the process.
Don't forget to visit the Stanbic Garment website.
नहीं,
This is how an insert will be done. You see different shapes here, here, here. Different designs. Each insert has a different design. Can you tell me why this? Why it should be there? There are different types of designs on top of each insert.
So to avoid ambiguous stresses, equivalent stresses.
Absolutely wrong.
To avoid impurities on the face of the chip or face of the tool.
Close, but not the answer. Both is simple.
Combination.
Both is simple answer. Complicated answer. उसके लिए तो कोडिंग डालनी है.
To avoid the combination.
Chip breaker.
Chip breakers. These are called chip breakers. These are chip breakers. These are just like speed breakers. Why am I showing you this picture? For the benefit of all, we will discuss with you. Right? Or we will discuss it in right? So, what are these? What is this feature called? And why do we need it? For chip breaking. So my chip
pages spring form of the बात करते हैं कि आगे के लिए जो जगह खराब करेगी पूल हो जाएगी ऐसा हाल तो होगी खराब है
why is chip breaker there? My chip flows on the chip breaker and hits itself. The tool drop or it breaks by its weight. So each chip breaker is different for each different material and depth of cut. If I am doing a finishing operation, my depth of cut is less. So my chip breaker will be very close to the cutting edge. So when my chip breaker is not in contact, what will happen? Chip will not break. So when I am turning away from the chuck, my chip breaker is not in contact. So what different the designers have done in this is, they have designed a chip breaker so that it comes in contact in reverse and forward direction. Right? Which comes to the next question which someone asked. Sir, this is the one you are. Which are the layers in coating? What are the different types of coating? This is the top layer. See, titanium carbon nitride has affinity due to titanium. It can stick to tungsten. So it sticks to tungsten. On top of this coating, we put on alumina. What is the role of alumina? It is heat resistant. Thermal barrier. This is a thermal barrier. And what is the use of this coating? TAM? If you look closely, this coating is here on the sides and not on the top. On the top it is black, same as aluminum. So what we do is, we do the coating of complete insert and then remove the top layer. So that should mean this coating is not required.
So why we done?
Absolutely good question. This is required for wear detection. Black color is not very visible in machining conditions. So when the insert gets worn out, we are never sure that it is worn out. So this is just, it used to be very good, it is still a very good coating for high speed steel. But on carbide it doesn't have any fit. This is just aesthetics. To make it look good, we painted yellow. Golden.
And to identification of wearing.
Is to identify whether it is worn out. Otherwise, if it had any purpose, it should have been present on the cutting edge. This is not present on the cutting edge. Interesting? अंदर से कह देते हैं जो सोया बात करेंगे. Okay, now the most interesting topic. You must have heard this word a lot. Productivity. Yes? What do you mean by that? What is the meaning of productivity?
Efficiency of production.
Efficiency of production. Yes. In simple, yes.
It is something like efficiency, but it should be always greater than 1.
We strive to be one in machining, but we never are. It is basically output over input. What do we get after the? So, in manufacturing, what is output?
The finished goods.
Absolutely. And what is the input?
Number of inputs depends on the
Actually, everybody is right. Actually, everybody is right. Okay, I'll ask like this. Raw material input?
Yes.
Oil,
everything.
electricity,
Yes, sir. Manpower.
है ना? Machine are. So what is input? Input is the physical things and intangible and intangible things that we provide to achieve the final finished product. Finished product is our final output. Right? On output, price of our product. For example, आज से ज़्यादा दूर नहीं जाते, 3-4 साल पहले, how much did LCD cost? 35-40 about 40,000. So that is the price of the product, price of a TV. है ना? What is the price now?
6,000-7,000.
है ना? Did any of the inputs
For the same brand, the cost is reduced no doubt.
competition is there, maybe not that much, but yes, it has gone down. अच्छा, we take both examples. पहले सिर्फ सोनी बनाता था, ऊपर 40,000 का बेचता था, फिर सैमसंग भी आ गया, फिर एलजी भी आ गया, अब आईवा सब आ जाते हैं, माइक्रोमैक्स भी बनाते हैं. But then, if somebody take out any part में उसको सस्ता करने के लिए I put one less part की स्क्रीन भी लगाते हैं इस बार, रिमोट भी डालते हैं. Did somebody put one less part? Did the cost of input material get reduced?
It has increased by the way.
It is increasing every day. सब्जी सस्ती नहीं हुई ना, तो no spare part is costing less per day, right? Are we on the same page? So the price of my product has dropped. The price of my product has gone up. What does that mean? क्या काम हुआ? प्रॉफिट कम. जो प्रॉफिट पहले मेरा 20,000 रुपया था, अब तो 2,000 मिल. So how to increase that profit? That is the challenge that all of us first of all has to understand that yes, this is a problem, this thing needs a solution. Right? Got it? The cost of my product is either same or going down. Either same or going down. iPhone 6 was launched at 68,000. Now it is available for 24,999. Have they put one less part in that? Apple cannot afford that, but they are selling it for less margin, less profit. So how do I make up for that lost profitability? Is what is called productivity gap. I can bridge this gap by manufacturing more number of components with the same set of people, similar number of inputs. It cannot be same because there are two types of input. One is constant and one is variable. Constant is, for example, the building. I need the building. If I make one part, I make 100 parts. Right? I need people to work, whether there is work or no. Right? So, what is variable cost? The more number of products I make, the more raw material I need, the more electricity I need, the more oil I need, the more tools I need. These are all variable parts. So when I am doing mathematics, how much my component should be sold in the market? This is the calculation which every organization does. This is called costing. What should the product cost to make and to sell? Right? So what are the different variables? Variable cost, fixed cost. I cannot fire people because the work is less or more. I cannot rent out my factory. कि आज काम नहीं है, आज शादी करा देते हैं. So it cannot be done. On the other hand, consumables, these new portions, if I make more parts, I will need more of these. Yes, I cannot throw away the machines के मेरे पास काम नहीं है. So what I do is I squeeze this. I do more work in the same time, in the same resources that I have. Right? What is that common resource which everybody has? Which is common to everybody? Everybody has same, even Bill Gates.
Time.
So, if I can do the same work in that time, I am being profitable. I am making 2 extra components, I am getting price for it. My capital investment is getting offset. For example, I have to cut 15 millimeters of material. Out of 50 mm of bar. There are 3 ways to do it. So मेरे को अब radially I have to remove 15 millimeters from a bar of 15 millimeters. There are 3 ways to do it. I do it with a WNFG case insert, and I take 4 passes of 4 millimeters each. For example, I do it with CNMG. I do it in 3 parts, 5 millimeters each. AP is depth of cut. Third is roughing, CNM, single sided insert. 2 passes. Comparison.
त्यामध्ये 12 सेकंड 16 सेकंड 8 सेकंड पॉवर 10 13 सेकंड
This is made in Swedish, so they have capitalized SEK, otherwise it is SEC. This is time. 22 seconds to do the same job, 16 seconds and 8 seconds. So, what does this do? What is the hypothesis?
Now you have to decide whether you want production or you want cost saving.
Exactly. So, I assume I got a better tool line at lesser depth of cut. If I made more components, I still save 1% of the total cost. If I get a better tool, like let us say I make 10% additional components, how much will it save? On eventual cost, it will have an effect of only 1%. If I, let us suppose, reduce the time by 10% only, I was doing it in 22 seconds, I have started to do it in 20 seconds. Then my eventual cost is reduced by 10%. How come? If I am making 100 components in a day, and I am starting to make 110, right? Only 10 components. Now the same resources, same cost, machine is same, man is same amount of salaries are given, same amount of. But now these 10 components are free for me. The variable cost is added, but then how much is variable cost? Variable cost is not more than 20-30%. This is the only portion of variable cost. This is capital cost. I am using the same resources to make those 10 components. So my profitability suddenly shoots up. On one hand, I am making 1 million phones in a month. This is a live example. Each month they make about 4 lakh odd motorcycles. So they have a capacity of 4 lakh motorcycles. If in a month they do not make 4,000 motorcycles, but what happens? Do they not give salary? Or they give out their factory to somebody? They make losses in that. The factory is meant to make 4 lakh. At 4 lakh motorcycles, they make a good profit because they are working in a competitive environment. In the month, they do not make good number of motorcycles. They cannot shoot up the price. Right? So the business today is facing the problem of productivity or profitability. The role which you and I have to play in this industry is to first educate and then explain how it is to be done. First explain that what is productivity, why is it important, and then show them the way how it can be done. One is theory and the other is practical. So the first phase is theory. First one has to understand what is productivity. That is what in this slide is shown, that if I reduce the tool cost, rough estimate, what is the machining cost of all the components of a car? एक कार बनाने के लिए कितना खर्चा आता है? कितनी मशीनिंग? एक कार के सारे पार्ट्स Notice how many rupees should be. Let us suppose Alto 4 lakh की कार. Machining cost. वैल्यू की बात करेंगे. 4 लाख की गाड़ी है. How much should be the tool consumption? How much tools should be consumed in making one car? एक कार बनाने में कितने टूल्स लगते हैं? पैसे 4 लाख की गाड़ी बनी, टूल कॉस्ट कितनी होगी? 50% में नहीं बात है, पैसे में 1 लाख से नीचे आओ और नीचे आओ और नीचे it is not more than 16 It is never more than 1600. Never.
16 से 16 से 16
1600 rupees.
1600 rupees.
4 लाख का 4% की जमा 16,000 16,000 It is never more than that. In general, it is 2 to 3%. I am assuming 4%. Otherwise, every car manufacturer makes it within 2 to 3%. And what should be the cost of machining a Boeing plane?
On an average, जो मशीनिंग कॉस्ट ऑन एन एवरेज 40% ऑफ रॉ मटेरियल.
Yes.
थंब रूल यही है और नॉर्मली द रॉ मटेरियल कॉस्ट आर वेरी हाई.
Exactly. Same is true with car as well.
Yeah,
Even car, even
raw material is high.
car manufacturer has about 30 to 40% cost of only raw material. The tool cost is nothing. It basically comes for free. So today I am buying tools for 100 rupees. Let us assume I can increase productivity and buy tools for 200 rupees. So my 2% becomes 4%. But my eventual cost is reduced by 10%. I save 8%. 8% of 4 lakh is too much for an organization. Each car they can save 8 lakh, provided they know what they are doing. Right? So this is all about productivity. For example, they have done some calculation. So if they are the tooling cost is $0.3 and $1.70 is the material cost, then total cost is if I lower the price of the tool, increase the tool life and increase the cutting data. Increase cutting data means reducing the time of calculation. I can save 15% of the machining cost. So the only solution to reducing profitability is increasing the production rate, increasing parts per hour. Right? That is the reason, because my fixed cost will remain the same. Even though variable cost will increase, my production cost is less. At a stage, the production cost again goes up. Why? Because my tools start to break. Because we are going out of implementation. Right? So there is an optimum line to this. And to decide what is this factor, then you remove. It cannot be controlled by probability. Any other question? Because after this, I will take some time for new innovations that we have been doing.
He wants to know we have that particular thing. I think you will have a chat. How do we select a tool for our operation?
Yes, I have a complete topic on that. We can do that. Coming,
He wants to catch it.
we can do it quickly.
Quickly you can do it. Just do a brief on it.
How can we select a tool for a particular operation?
मेटेरियल जॉब टू जॉब, टाइप ऑफ ऑपरेशन, पार्टिंग चाहिए, स्लिटिंग चाहिए, बहुत है सिलेक्शन होता है.
As the picture depicts, it is how we. This is the only way to do it. So basically, we have differentiated all the tools in 3 different sections. One is turning, milling, and drilling. And make this quick. Is everybody aware what is turning, milling, and turning and milling? Turning and milling is drilling.
हैंडलिंग आप छोड़ दो, तो कोई सिलेक्शन वो वाला सिलेक्शन है, ये बोल रहे नहीं छोड़.
उसके लिए ज़्यादा नहीं करेंगे.
नहीं इसमें मिलिंग और
तो what is the difference between turning and milling? मोटा मोटा जल्दी जल्दी. What is turning? स्टेशनरी क्या होता है? टूल्स का क्या है? चिप्स कैसे निकलते हैं?
Depends on the material. Depends on your material.
But steel में aluminum में steel must be material. It is a long it is basically a long. मिलिंग की बात करते हैं, क्या रोटेट करता है? स्टेशनरी क्या है? टूल रोटेट्स, जॉब इज है ना? चिप ब्रेकिंग कैसी होती है?
Discontinuous.
So one less problem in milling. It is chip breaking. Turning देखने में आसान है, but due to chip breaking, it is a complicated operation. That is why we have so many chip breakers in turning and not in milling. Because chip breaking is never ending. In milling we have different grades, but we have very less geometries. What is geometry? The shape which we make on top of the right? So the major difference between turning and milling is chip breaking. That is what amateurs tell. Experts tell turning and milling में chip breaking का difference होता है, right? So how do we decide which tool to use? We have all these material just to cut metal. Which to position where? By the way, this is HSS, high speed steel. GC is coated carbide, gamma coated. GC is for gamma coated. CD is cement. CC is ceramic. CB is cubic boron nitride. And CD is crystalline diamond. ऊपर से शुरू करें, ये कहाँ पे यूज करते हैं?
हार्ड ग्लास वाइट को भी फिनिश करने के लिए डायमंड लगाते हैं.
Actually, half of you are right, half of you are not right. Diamond is only used for non-ferrous material. Why? किस चीज से बनता है? 700 डिग्री के ऊपर क्या हो जाता है उसको? 700 डिग्री के ऊपर वो कार्बन डाइऑक्साइड बन जाती है. So जब हम स्टील नॉन फेरस जब हम फेरस मशीन करते हैं कोई भी लोहे का पार्ट कास्ट आयरन स्टेनलेस स्टील या स्टील, तो उसका टेम्परेचर एवरेज कटिंग का टेम्परेचर कितना होता है? मोर देन 1200 डिग्री. जैसे ही 700 के ऊपर पहुंचा क्या होगा? वेपोराइजेस दिखता है. तो अब यहाँ पे हम हमारे को हार्ड पार्ट मशीन कर रहे हैं जैसे कि आपने एक्सप्लेन किया, तो मेरे को क्या लगाना पड़ेगा? आर्टिफिशियल डायमंड. दिस इज मैन मेड डायमंड. दिस इज cubic boron nitride. Invention is the mother of creed. We needed a material to machine those.
style as a diamond.
It has different properties, but it is harder. It is next to diamond. Diamond is the hardest.
The same category of the heart. No, but
See, it is lesser, but it is much higher than all of them combined. It is slight. The difference is very less, but both applications are different. We cannot run this on non-ferrous. CBN cannot run on non-ferrous. On non-ferrous, either you run this or you run HSS or uncoated carbide. The needs are different. The material is sticky. The non-ferrous material is sticky. It tends to stick, jump jata hai. So to do that, I need a sharper edge. I need a surface which doesn't have coating. Coating is just like paint. We हम दीवार के ऊपर करते हैं, तो वो edge rounding कर देता है. वो sharpness खत्म कर देता है. So that is the reason we use only sharp cutting edges for non-ferrous. The material is like butter.
yeah.
So we need a sharper knife to cut tomato cut. We need a sharper knife. Apple can be cut with anything because it is hard. Tough things are difficult to achieve. I would prefer not to cut a soft material. I would rather form it. I can give it shape. Because cutting is very difficult. It is very difficult to get off. It is basically a shearing process, and it is not. It has ability to bending, so it is very malleable. It is not letting us shear it. So I would rather form it. I rather use its malleability to my use. So I use uncoated. Right? So where is diamond used? In non-ferrous. Where is CBN used? Where material is hard. I need hardness in the cutting tool. Only there it is used. And where is high-speed steel? Even today we use it. There are some applications. This is where we started our machining. We started from here. Started machining with HSS tool bits. We still use HSS in some form, some operations. Why? One is cheaper, but then we discuss the productivity part. It can never be cheaper. That's it. It is very easily bendable. So when I am drilling a very long hole, if my material is very brittle, it will reflect and break. The steel allows a bit of freedom to move. So we use in long drills, we use in tabs, the threading we do. The difficult operations till today have been done by high-speed steel tools. Right? Why geometries we have discussed? Different materials with different geometries. Different type of features, I would say. What is the difference between milling and turning is that? Right? But here is shown is rake angle. What is rake? Rake angle.
Triangle between the chip and the rake face of the tool.
Yes. The top face of the tool and the axis of the component.
Power value 0 to 15 alpha.
Right. 3 for aluminum and about 3-4 degrees for steel. So yes.
So for what material we use negative negative?
For cast iron and hard materials, where the chances of my edge getting broken are more, I use negative rays. But still there should be some way to make the shearing happen. So that rake is provided by tool loading. Nothing can machine without rake. Rake is the clearance between cutting edge and of course the main clearance comes from the clearance angle. So that my bottom of the insert doesn't touch the job, it doesn't vibrate and stuff. But then the primary rake allows you to machine. Either it will be on the insert or it will be on the tool. But nothing will machine without a rake. There is a thing called 0 degree rake. That is called negative. That is the most negative machining has. There is nothing below 0 degrees. Right? The same terminology applies to the milling as well. We need rake and clearance machine. Advantages of negative style, 0 degree rake. We can use the both sides of the insert, top and bottom both. The edge strength is more. Over here, my corner is very weak. Here, my corner is very strong. It is mainly used for external machining, but in bigger diameters we can use an internal diameter. It is mainly recommended on heavier machining patterns. On the other hand, if my job is very weak, I should use a difference between it is showing that the rake is provided by the tool itself. Over here there is no chip breaker, flat insert, hence no rake. If I have a chip breaker, my cutting forces will come down. The higher the rake, the lesser force will be required to shear the material. Downside, plus होगा सर, ये मेरा काम आसान हो गया. I am using less force to cut the material, but my edge becomes weak, so I give it some negative weight, right? Chip breaking. At the cutting zone, the temperature rises up to 2800 degrees centigrade. At the cutting zone, it is about 1400 degrees. This is cutting zone. Prolonged exposure to heat causes tool failure. To do that, we remove the heat from the system. How? How do we remove this heat from the system? Please break the chip. The chip takes away 80% of the heat. Engineering is nothing but common sense. And somebody somewhere was putting up their pride when they designed the chip breaker. If I am not breaking the chip, all the heat is remaining in the system. Either it will go into the tool or the job. In both the cases, it will be harmful. If it goes into the job, it will surface finish हो जाएगा. It will be detrimental to the surface finish. If it goes to the tool, it will reduce the tool level. either by itself or against the or against the job. This slide here shows the approach angle. At what angle should I approach the job to curl the chips, to give them direction, in which direction the chips should flow. Similarly, the shape decides how many corners can I have in a picture. The more the better. But if I have too many corners, my capacity to make depth of cut becomes less. So this is the most common used insert in the industry. After that, triangle. It's not so bad. But the triangular insert is second one. First one is diamond shape. Then comes the role of corner radius. What is the deciding factor of corner radius? How do we decide corner radius? It is basically dependent on two things. One is how much stable my setup is. First is surface finish. What is the surface finish I require? The more the radius, the more feed marks it will be. The bigger feed marks it will be. So for finishing we use sharper ridges, lesser corner radius. But we cannot use very less corner radius because one, it will move very slow. Second, there is a chance of it getting broken. So in roughing we use bigger radius. In finishing we use lesser corner radius. Same thing. If I increase the radius, I can go at higher feed rate. This is just a synopsis of what we discussed. So the main factor in this deciding which tools to use is first of all which material I am going to use, and then whether I want to use double-sided insert or single-sided, and then whether my tool should be positive or negative. Fourth is how much rake it should have. Fifth is how to break the chips.
What is the minimum P and T? Three kinds of subsystems.
P is for speed.
chip basis में हो गया लॉन्ग चिप P है, शॉर्ट चिप्स जो होते हैं वो K है, और जो मीडियम चिप्स होते हैं वो M ग्रेड है। फिर उससे सेलेक्ट मटेरियल इतना सिग्निफिकेंट नहीं होता जितना चिप पॉपुलर है। चिप ब्रेकर्स आर बेस्ड ऑन द चिप फंक्शन। P M K हाँ मोस्टली फॉर्म है। K is normally K class standard because it comes out with a dust. जो भी मटेरियल लकड़ी वो भी के लिए हाँ अब जब से पहले आप वो बनाया जाए
P is depicted by blue, which is represents steel. M is for stainless steel. K is for cast iron. N is for non-ferrous.
non-ferrous एक और है उसका
S is for superalloys. Superalloys में क्या आते हैं? Titanium, nickel, chromium. Right? And there is one more. That is called H. What it should be? Hardened. Hardened components को हम किस चीज से मशीन करेंगे?
हाँ आपको 50 RC का मशीन है
Hardened steel. What should be used to machine that? Which cutting tool material? Hardened steel only. Carbide. CBN. We should use CBN to machine hard carbide.
Today we are machining up to 40 to 45 HRC by tool itself. Grinding हमने इतनी जल्दी देते हैं। जॉब से निकलता है अपने आप नहीं और ये सीधा निकलता है
Somebody mentioned that there is one more way to remove the heat from the system. And that is cutting light. Coolant. Cutting light.
what the rusty हो जाएगा
It forms a thin layer between cutting
स्टील
It forms a very thin film in the cutting tool. So one is cutting light. Other advantage is the surface finish of the finished product gets better. Third advantage, if you are using a food cutting oil, you do not need post oil application to prevent from
The fourth is spindle भी full रहती है
आपके सिस्टम से हीट बाहर निकलेगी
ये spindle full रहती है spindle लाइट पड़ जाती है but coolant पानी मत यूज करिए पानी it will all be rusting यूज करो हाँ air is one air is used compressed air as a coolant is used it is used
In some applications, we recommend only air.
only air
Right? Anything else that somebody has input? Because after this, I only have 10-15 minutes of new products, nothing more. If there is some topic of interest you want to discuss, I can have it there. Everybody can be part of it.
we have some videos of some components difficult components अच्छा फिर showing mechanical component बनाने का कुछ
Medical से मेरे पास presentation
चलिए technical कुछ components बनाते हैं मतलब actual kind so then there will be more clarity on how it is done हाँ नहीं we can take a break and then start
Sure.
ये मिलिंग ड्रिलिंग सब ऑपरेशन बना रखा है
नहीं कर सकते, क्यों नहीं कर सकते?
दोनों तरीके से हो सकता है, ऐसे भी हो सकता है और बोरिंग से भी हो सकता है। होल को एनलार्ज करना, व्हाट इज बोरिंग इज एनलार्जिंग ऑफ एक्जिस्टिंग होल, एक्जिस्टिंग होल को बड़ा करने को बोलते हैं बोरिंग ऑपरेशन। ठीक है,
ये भी बंद कर दी।
और उसके पास एटलीस्ट 2 शॉट्स है ना, याद है ना? ऐसे ही मशीनिंग में भी है, कोई भी तरीका गलत नहीं है, बट व्हाई डू वी डू इट? हम एक ही काम को 2 तरीके से कर सकते हैं, कौन सा कर सकते हैं? टाइम में ज़्यादा लगेगा, इसमें कम लगेगा, बोरिंग में ज़्यादा लगेगा।
ऑप्टिमाइज प्रोसेस सेलेक्ट करो,
ऑप्टिमाइज प्रोसेस कौन सा है?
मींस एक्यूरेसी
किसकी एक्यूरेसी ज़्यादा है, किसमें टाइम ज़्यादा लगेगा? बिलिंग की एक्यूरेसी ज़्यादा है काम में,
ज़्यादा है,
और टाइम किसमें ज़्यादा लगेगा? दोनों आंसर करते हैं, ये बहुत आंसर कर रहा है, वेरी गुड। गिरते हैं शहसवारी मैदानी जंग में, बहुत भी क्या गिरे जो मतलब एटलीस्ट यू अटेम्प्टेड द आंसर। मिलिंग ऑपरेशन इज अ स्लो ऑपरेशन, वी डू नॉट वांट टू डू इट। उसकी जो एक्यूरेसीज हैं, इवन दोज आर नॉट वेरी एक्यूरेट बिकॉज़ वी आर डूइंग इट विद 2 or 3 inserts which are never at a same plane. So it never gives you a good surface finish or very accurate hole. But why do we do it? I have a job where I want to make dia 32, dia 40, dia 43, dia 46. To do the boring operation, I will have to buy 4 different tools. But if I have only 1 milling cutter, I can do everything by the. This is where computer programming doesn't help. We can think on our feet.
Plus speed is higher, though accuracy is not good, the finishing not. Speed of milling is higher, we have multi-point.
Speed of interpolation is very high. But boring में we are dealing with only one axis.
Yes,
Only z axis is working. So that compensates. So both may or may not. Time difference is not so much. If my bore is deep, then boring is faster. If my bore is not very deep, then boring is faster. Okay? So there is no thumb rule which is right and which is wrong. It is us to decide which process should be applied at that particular application. ठीक है? Now I'll show you a few videos of turning. The first one being rough turning, then it will be medium turning, then it will be finish turning, and then it will be grooving, and then it will be threading. So we will understand what are the operations. Rough turning. The depth of cut is high. Medium machining, depth of cut is medium, speed is medium. Finish cut. This is medium machining, that was right. This is the finishing insert. Look how close the chip breaker is to the cutting edge. To break the threads up. Add smaller depth of cut. See how less is the depth of cut. And still the chips are breaking. Which type of insert is this? This is a positive insert. This is used for extreme finishing, where we need very less force. The rake angle is very high. See the surface finish. The chip breakers, very close to the cutting edge. Almost at the point.
आजकल सचिन we are achieving 6.4 micron finish by hypertrophy.
Yes. Now we can do that in art pattern.
Today, most of the industries, grinding is getting eliminated. The grinding finish is being achieved by inserts.
In one operation, we do.
No. Yeah, you're replacing a complete operation machine itself from the system. Grinding machine is obviously a very costly machine, very accurate machine, occupies a lot of space. And आप loading unloading इधर से उतारो उधर लगाओ उधर ट्यूब करो यार एक ही setting में with the inserts they have today, the quality of inserts and the speed and feed available in the machine, you are able to get grinding finish. That is approximately 4.8 to 6.4 micron.
So for operating the grinding finish,
What is the depth of work?
What is very low. Speed and feed.
These are obvious challenges. There is one challenge which is not noticed by us, but still it is. If you ask any owner of the company, that is the biggest challenge. How many people you sir think are going to work on a CNC grinding machine, are willing to work on a CNC grinding machine or grinding machine? Not very skilled people are available to run those grinding machines.
Grinding machine without skill cannot run, even though they are sales. Because compensation has to be fed manually.
And considering that not many young people are coming into our industry, not many people are left to run the machine.
Very costly machine.
Very costly machines, people are not available. So what do? We do it on a CNC. CNC we still have a very good base. Everybody who comes out of polytechnic, they are very good to run the CNC. Yes. This is ideal machining operation.
ये बोरिंग बात है, तो बोरिंग नहीं समझ रहा है.
Grooving, parting off. Parting off. Threading. Face filling. When we machine the top face with a cutter, we call it as face filling operation. This is called shoulder milling because it is generating a 90-degree angle. A
Shoulder or side and face.
What is this operation? Because here, although the shape of the cutter is different, still the operation is what operation is this? आपको कोई वो नहीं चलेगा गलत फिर दे दो ये तो सिंपल है अभी तो किया थोड़ी देर कौन सा ऑपरेशन है स्लॉट वाली किसने बना तो दे मैंने कराया नहीं था this is slotting basically this is the shoulder milling operation as well but क्योंकि बॉल दोनों तरफ है so we call this a slot milling
आप लोग कुछ क्वेश्चन तो पूछते जाइए मामला ताजा है कैसे हो जाएगा काउंटर सिंकिंग नहीं पता अच्छा ये कूलेंट कहाँ से आ गया
वैसे तो नहीं पड़ा होगा सब
नहीं थ्रू कूलेंट नहीं हाँ क्योंकि ये पूरा नहीं था दोनों चीजें हैं काउंटर सब होता है ऐसा बन जाता है वो ड्रिल से बनता है और काउंटर बोरिंग होता है कि बोर के ऊपर एक और बोर बनाना पड़ेगा ये देखो ऊपर जो बन रहा है वो काउंटर बोर्ड ये काउंटर यस दिस इज काउंटर
this is counter this looks square but mostly it is round but any surface which is on top of a hole is basically a counter bore. Why do we need a counter bore? To set the head of the board. So basically counter is not very accurate. In general, if we are drilling is never a final operation. Drilling is always rough. Drilling is final operation only in one case, and that is counter drill and counter. That's it. Otherwise, it is never a finishing operation. There is always a post operation. It may be tapping, it may be limbing, it may be boring, but drilling in itself is never a final operation. So whatever surface we get should be acceptable. हाँ जी हाँ तो tapping is the final operation, not the drilling. the tap generates its own surface.
You want a tool internal thread. Yes, tool से टैपिंग इनके पास है, इसमें टैपिंग तो सकता है, इससे भी कर सकते हैं, टूल से भी कर सकते हैं, एक्सटर्नल थ्रेड बना वैसे वो भी बन सकता है। नहीं, मशीन पे टैप करता है, मशीन पे टैप करता है, मशीन टैप और वो सिंगल टैप से होता है, उसमें 3 बार टैप नहीं हुआ।
There are 3 ways in which threading can be done. One is thread turning, one is tapping, and third is thread milling. Like we did the helical interpolation with milling cutter, we do the helical interpolation with thread milling. I do not have a paper pen.
नहीं होगा।
Generally, we use 2 or 4 cutting edges in turning. For the first time, Sandvik has introduced a tool with tangential mounted turning inserts. The advantage is, one is number of cutting edges are more, other is rigidity. You have this much 16 mm of carbide to support, which results in very good surface finish and low vibrations. So this is the new innovation which we had introduced last year.
कॉप्टो वाला है मेरे पास,
Capo.
कॉप्टो वाला दिखाइए। हाँ ये चलेगी।
Another unique feature about this tool is the coolant is coming from both the sides, from top and from the bottom. As per our experts, the coolant from top is responsible for breaking the chips and making the surface finish better. The coolant from bottom is responsible for higher tool life. It takes away the heat from cutting tool.
हाँ ठीक है। रिपोर्ट में ये नया
This
डिजाइन
is the standard tool holder.
टूल होल्डर से
Why is it special? All tool holders are special. They do something, so they are special. At some point of time, all tool holders were special.
now
Slowly and
product
slowly
standardization है।
It is all dependent on the sales. If a product is sold in higher quantities, it becomes standard. This is the tool holder. This is the top coolant nozzle. Bottom coolant nozzle is in the shim.
हाँ बहुत इनिशिएटिव कैपिटल भी एक है। modular system. The same molder, different things.
Same clamping can be done for all the tools. Turning, milling, drilling, boring. This is a shoulder milling method. So what they are showing is the tool, the machine is fouling. So what they do is they put extension into it to increase the length. Same tool, you do not change the tool, just add extension. Length is increased. The same tool. This is the extension part. Clearance.
आप बैठ जाओ।
Look, पहले milling tool था, अब turning tool.
और लड़ा था extension हमारे इसका।
सेम सिस्टम में नॉर्मली टर्निंग और मिलिंग भी अलग अलग होती है, मशीन्स भी, क्लैंपिंग भी, सब कुछ. दिस इज कॉमन फॉर बोथ टर्निंग एंड मिलिंग. कैन बी माउंटेड ऑन नॉर्मल मशीन as well. इसका अडैप्टर मिल जाता है, जो भी मशीन आपके पास है उसमें कैप्टो के कुछ विद एक्सटेंशन.
एक BT50 के लिए होता है। सबके लिए
BT30, HS के, DBT40, every
मतलब इतने सारे अडाप्टर लगाते नहीं चलेगा।
so same tools can be utilized on multiple machines. So if a shop has 15 machines and has different tables, they can actually mix and match the tools. They do not have to invest more. Last but not least, some interesting production.
Evacuation and process security can make or break your production efficiency. Reaching superior levels of reliability with the tool-like predictability needed for secure and trouble-free production processes. Coronel QD is changing the game for milling grooves.
Slitting cutters with internal coolant.
Internal coolant and geometries developed for secure and productive milling. The longer hands, silent tools, dampened adapters take care of vibration. Coronel QD, your solution for clean, high-quality grooves. In heavy roughing operations, predictable tool life is critical to facilitate production planning and prevent tool breakage. The Coronel Pura heavy-duty end mills are developed for removing a lot of metal in a short amount of time, while bringing your workshop the reliability needed for demanding roughing. With proven endurance, this is your first choice for roughing with solid end mills. The new heavy-duty end mill thrives when being pushed and often reaches its best performance with high cutting parameters, making it an achievement to rely on. Imagine reducing lead times to the extent that a complete component is finished in 1 week or even a couple of days from order to delivery. With know-how being an increasingly scarce resource, acquiring the latest solutions is of critical importance to stay ahead in the transforming gear manufacturing landscape. The software InfoMilling 1.0 is the next step in shortening lead times for gear production. The software only takes a few hours to learn. Then you are set to change the programming when machining different gears, removing the need for a specific tool for each gear profile. This reduces component delivery time to a matter of days. InfoMilling, agile VR manufacturing. For more information about our new cutting tools and solutions, visit the Sandvik Coromandel web.
Any questions?
We have some time. कुर्सी दे दो ना मोबाइल पे। नहीं वहाँ वाली कुर्सी
नहीं,
नहीं मैम क्या है
नहीं।
Sir, do we have any gear cutting
ये gear cutting कर
exclusive?
बोल गया नहीं दिख रहा
Only gear machining and tapping are the operations left in machining that are still done by high-speed CPU. Now the situation is, modern machines have come with so much high power, higher motors, very good rigidity, but the tools are very old style.
नहीं बट ऑप्स तो आ गए ऑप्स विद इंसर्ट सेट
Only recently insert type of have started to come, and Sandvik took the lead in that.
ये हेलिकल कट Any other questions?
By the way, most of these videos are available online, YouTube and Sandvik site. And one more thing, if you want a diploma for training similar to this, there is an online course available, free of cost, for everybody on Sandvik site. Go to the knowledge part, register for the training, study the material, and give online exam. If you clear the exam, then you will get diploma.
So we'll be given a visa for Sweden.
Star mark.
Then I will do it.
Sweden till Noida.
ये पासपोर्ट में भी स्वीडन एंटर नहीं स्वीडन स्विट्जरलैंड करवाना है
जब बोलो. So this is a good opportunity. First of all, knowledge gets better. Other is you get a good certificate.
Yes, send me certificate as well.
And it is signed by our CEO.
Is it a time bound diploma? No.
It is basically online course, and whenever you get time, spend 2 hours study, and then do whenever you want.
So you can't offer the materials.
No need, because it is available online. It is available online, so I don't think we can always print it or something. But actually, it is in a flash presentation.
Yes.
So flash presentation, I don't think we can see. So it is very informative, and we do not need it for more than once. If you have gone through once, you can always access the site.
But table कुर्सी तो लगवाओ ना.
Well, thank you very much, sir, for all those wonderful sessions that we had full of knowledge. Hence, we are sure to gain a lot of keenness towards industrial approach and academic approach by the sessions we had today. And now I request Professor Nitin Srivastava sir, Head of Mechanical Engineering Department, to present a memento to Mr. Sachin Atreja sir as a symbol of gratitude and honor.